Today I'm going to show you how to run the Wireless Protocol Suite 1.60 version, go through the features, capture a file and show you how to save it. When we run the Wireless Protocol Suite, you get this page and it shows you recent capture files that you looked at. We also see that we have an X240 connected to the software. These are some sample log files that we add in so that you can look at the sample files and get a feel for the Wireless Protocol Suite. Getting started, we have a quick start guide, a user's manual, and all of that information will help you get familiar with the X240 Wireless Protocol Suite. We're connecting to what we call the data source. So now we'll have a look at the window that comes up with all of the different panes. Let's go through all of those. First thing is on the Analyser bar here, you can see that there's an X240 hardware connected, the serial number, and we can see here the different licenses that we support on this device. Classic, low energy, Spectrum and Analyzer excursion mode, 802.11 A, B, G, N, and AC if you have a license for that, and 802.15.4 Zigbee. We support a license for that as well. So that's all the licenses that are on this device. Here we have record options. So this is where you set up which technology you're interested in capturing, BR, low energy, it also includes 2 megabit LE. If you wanted the X240 to capture Wi-Fi, or if you wanted the X240 to capture 802.15.4. There's a Spectrum Analyzer feature which you can turn on or off if you have that feature included in your device. So one point is you only use one at a time. So it's either classic or low energy that you're interested in, or Wi-Fi or Zigbee. So the X240 can support all of the technologies, but you only output one at a time. Wired means you have some pods that we can connect to the X240. Do you have a picture of those? Yeah, so these are the pods that are connected to the X240. So these are used for HCI, host control interface connection, or a logic analyzer. You can have up to 8 logic lines on each pod, up to 16 logic lines for marking your captured log file information, or HCI or both. So they're used for that. Then to set up the pods, pod 1 and pod 2, you can set it up as a logic analyzer, or you can configure it as a HCI UART serial analyzer capturing the various protocols, transport layers, H4. There's an auto baud rate which we have just added, so it will automatically figure out the baud rate of the serial connection. Or you can set them manually. So that's how you set up your pods, either for HCI, host control interface, or for logic lines, up to 8 logic lines input. If you want to look at Wi-Fi, then you need to have a Wi-Fi technology selected. Then you can go into the Wi-Fi window and select whatever channel you want to decrypt, decode, capture. The Spectrum view will capture all of the channels, but the decoding of the packets on one channel only will be whichever channel is in this window. Channel width, you can add that. We do have a scan facility added so that you can scan for devices, or you can enter in and filter in the Wi-Fi MAC addresses. You can add a Wi-Fi MAC address here. Okay, so that's used for setting up the Wi-Fi analyzer. Excursion mode enables the X240 to be used for capturing data as a remote logger. The use case for this that it was developed for was in the automotive industry, cars going on test drives on the autobahn or the motorway. The X240 could be in the car without a PC, in excursion mode, what we call excursion mode or journey mode, and capturing the Bluetooth activity inside the car. Then when you come back to the laboratory or your development environment, you can take that log file and look at it in the software here. Actually, to get the log from that device in that state, then you manage your excursion mode captures from this icon and this field here. If you had a file in there, it would be listed here, and then you can look at it as you like. Excursion mode in general mode, there's an automatic gain, a manual gain. Automatic gain will automatically adjust the input or the receiver front end gain of the X240 depending on the signal strength, not to over swamp your X240 receiver if the signal is too strong. Or you can have a manual gain where you could cut out any weak signals in the background and just concentrate on a local strong signal that you're working on your bench. There are some filters there. You can enable filtering in only LE packets with a given Bluetooth address. So you can tick that box and add specific BD addresses here so that you can only filter in those devices. There's also an RSSI receiver signal strength indicator. Enable filtering out packets with RSSI less than cutoff value, and you can set your cutoff value here again if you wanted to filter out any noise in the background, weaker signals. So make sure they're set as you want them, because if you have this one set, then maybe you don't realize it and you might not capture the address that you were working on. Okay, so that's the record options, and that was this icon here that's used for your record options. Then we have an analyze option. So this is to filter in a low level filter of maybe you don't want to see the inquiry packets or the paging packets, null poll packets. So it will filter those out and make your log file smaller, less clutter. There's a security events here, and this is where you would set in the long-term key for encryption in low energy or link key in classic Bluetooth. So when we get a pairing happening, we will see this pane will populate automatically with master address, slave address. Then if you need to enter the long-term key manually, this is where you enter that long-term key so that you can decrypt the packets. That brings us on to the start record button and the start analyze button. So the start record button works when you press that, you start recording packets that are in the background in the vicinity. And this is a new pane that we have added here. So you can see that the device database, this populated automatically. So these are captured devices. These devices are in my environment right now. You can see that they're live. These were previously captured devices, and you can see here I have a star. A star means I make this device a favorite. It will always be there. It will always be on top. It's a previous device sensor tag. It's not in the capture device because it's not live. I'm going to turn it on right now. And immediately you see when I turn it on, it comes up here in the sensor tag up top because it's a favorite device. And I will capture packets from that device. I am capturing packets from that device. When I tick that box, you can select all of the devices or just one device. And then when you start to analyze, you get the packets from that device coming into your summary pane. And here you can see all of the advertising packets coming in here. And the device database is more or less grayed out. You can see here that it's live. The only thing that's live on it is the search tab. So you could search for a device. You can see it selects that device. So it's a very powerful search facility. There's a tab up here that you can have show active devices only, so we're only seeing the active devices, or you could see all of the devices and you can see lots and lots of previous devices that were captured here previously. There is a wired device here, so if you remember, we set up our HCI or logic analyzer pod 1 and pod 2. If you want to capture the data from those pods and see it here decoded, then you would select pod 1 or pod 2. That's the device database. That's a new feature we've added, integrated into the complete window here. We did have it as a separate window previously, so it's much more intuitive now. You can see it behaving from a live capture. We have also a tab down here, the decode pane, and this is decoding packets that I have selected here. There's a follow live or stop scrolling here. I'm not following live here now, so I've stopped it. So if I select a packet here, then you can see the decodes from that packet. If I select LE packet tab, then it opens up the LE packet tab decoded information, or whichever tab is selected. And then the raw data from that packet is shown down here in the raw data. When I select a field in the decode pane, it'll show me the raw data, the actual bits in binary and hex down here on the raw data pane. You can move these windows around if you wanted to have the device data pane over here. You can have it showing wherever you like. Here we now have the device space and we have the summary pane here, so it created a new tab and shared that space with the summary pane. But I think it's good to have it sharing over here so we can have decode and device database. Down on the bottom here we have various panes as well, so different tabs. This is the packet timeline, coexistence, packet error rate, throughput utilization, and statistics. So on the timeline here we have also a BR/EDR and a LE tab. We're not capturing any BR/EDR, so that's why that is blank. We're capturing LE packets, and this bar at the top represents the complete capture. All of we're recording here, so it represents a complete capture. If I make it follow live again, you can notice this little window here comes over here and we're following the capture live. Now there's nothing happening because my device stopped advertising. If I start it again, we start to capture the advertising packets. It times out after a while. And again, this window is following the packet timeline, so the packets coming from this access address, the advertising access address. You can zoom out and in on that, of course, and then you can see some very intricate timing between the advertising packets. If I scroll that, stop that, and just look at here, this is channel 37, channel 38, and channel 39, and the different timing, 545 microseconds spacing between them, and this is the timing between the advertising packets bursts that you're receiving. So that's the packet timeline, looking at the timing between the packets on specific access addresses. Coexistence, this is looking at the background. Again, let's follow that live. Yeah. So this is spectrum view here that we're following live. So what we have here is from left to right, and let's make it a little bigger, timeline from left to right over time. And you have 1, 2, 3, 4 different scales here, 0 to 79, that's 0 to 78, 79 channels, that's classic Bluetooth, the blue color. The green color is low energy channels, 39. The orange is Wi-Fi channels, 0 to 13, 14. And the violet here, or purple here, that is 802.11 channels. So depending what technology you're coming in here, it's telling us we're recording LE. So I know that these green packets here that I'm seeing here are low energy packets coming out spaced at channel 37, 38, and 39. That's on your low energy spectrum. This blue heat map that you're looking in the background, the blue dots and blue bars, that is a spectrum analyzer. So you're looking at the 2.4 gigahertz spectrum energy levels in the background, and this blue bar here that we're seeing here, that's a Wi-Fi channel, the Wi-Fi running in the room here, and it's running on channel 1 here. And you can turn on and off that spectrum. If you turn it off, then we don't see the spectrum view. If you turn it back on again, you see that. It's a very useful spectrum analyzer view. These other small packets here, or the small bursts of energy, would be my mouse running in the background, keyboard and mouse, and other low energy devices. As you can see, there are lots of low energy devices changing addresses here all the time. And again, you have the complete bar at the top representing the complete capture. My device has stopped advertising again. So the capture continues on, but we're not capturing any more packets because there are none for that device. I can also show you the packet error rate by channel number. Again, go to the LE tab. This will show you the complete capture bar here. If I reduce the window down here, you can see 39 channels. That's all of your low energy channels, and we're only advertising at the moment, so we only see channel 37, 38, 39. Throughput utilization, again, you can see your complete capture window here, or the bar here, and here we show you BR/EDR bits per second if you're capturing them, low energy bits per second, and Wi-Fi bits per second. So again, close that window. This window represents the expanded view below, and it'll show you in bits per second what you're transmitting. If I move the window where there's no data, you can see here our LE bits per second. reduces. Statistics view will show you all of the different types of packets in a percentage format. So LE 1 megabit per second, that's all we're transmitting here. Advertising, scan requests, scan response, and a percentage term showing you what level of packets that you're getting. Now I can show you how to save the data that you've captured. There are several ways to do that. There's an icon here which save as, and brings up this window, and you can see where the default location for saving the capture file. So all you can see through this window from the application is the CFA file, the CFA extension. That is the data from the analyzed data that you have selected here from the device that you have selected. So there are other hidden files in here that aren't visible through the application. But if we look at, if I take a copy of that and I look through the Windows bar or application, then you can see that there are a lot more files in here. You have your CFA file, FSC, SCAP, and SWD. SWSD, that's the spectrum analyzer capture. If you have that on or off, that will be populated. That will be a big file. Then you have the SCAP file. This is Sodera capture file, we'll call that. And that includes all of the devices packets, all of the information. Whereas the CFA file only shows you the information that you've decrypted or decoded up here on Wireless Protocol Suite. So the CFA file you can see here is much smaller than the SCAP file. So it's a nice way of file management, and if you wanted to share just the capture file, the CFA file, with somebody, it's a relatively small file that you could send by email. That's one way of saving it. Another way would be if you wanted to start a new recording, then you will get prompted to ask you, the capture file has not been saved, would you like to save it? And then you can decide. Or if you close the application altogether, then you will be prompted also giving you the choice to save the file or not to save the file. So there are different ways to save it, and then you can come back at any time and look at that file. If you want to look at just a log file and not open up the live capture, then of course you can look here and you can see all of your previously saved files. Here's one I can open up here as a previously saved file, and the reason I'm opening this up is just to show you the encrypted data. On my device that I was using in the live capture, it's not using encryption, so I didn't show you that. So here you have SMP, which is a security management protocol here. You can see that encryption is enabled here. This device is encrypted. And if I show you the decode pane here, you can actually see the long-term key for that capture, for that connection. In order to enter, if you didn't have that, that long-term key and you needed to enter it manually, you can do that on the security pane. And here is where we can enter the long-term key manually in this field here. You can see here there was a connection. This connection here was the master and slave device, and it just works here. So it was able to, the protocol analyzer was able to figure out the encryption or the long-term key automatically, and it was able to fill it in. But if your devices are recent devices and the analyzer is not able to crack the code, then you will need to enter that long-term key manually yourself. Thank you for your time and looking at the Wireless Protocol Suite from Teledyne LaCroix. If you need any more information about our Bluetooth products, be sure and contact us. We'll be happy to help. Thank you. Bye.